Hello everybody, my name is Nicolás Pérez Moncayo and I'm going to tell you about the influence of waste glass powder used on the properties of alkali-activated slag mortars based on response surface methodology. In this study, the effect of waste glass powder as a potential cementitious material on the withstand drying shrinkage and sulfate attack resistance of a slag mortar activated by the mixture of water, glass, and sodium hydroxide was evaluated. Alkali-activated slag AAS binder reportedly exhibited excellent mechanical properties and durability, such as higher strength, higher chemical resistance, higher resistance to freeze-thaw cycles, and higher resistance to high temperatures than ordinary Portland cements OPC. The table 1 shows the chemical composition of these materials. The strength of the 13 samples are shown in table 4. The suitability of this model was determined by the analysis of variance ANOVA, which is shown in table 5. The interaction effect between sodium oxide equivalent and glass powder content on the flexure and compressive strength is represented by 3D response surface plot in figure 2. It was observed that H referred significant decrease on both sides of the peak, which indicated that the flexure and compressive strength of the AASGP mortar increased first and then decreased with the increase of sodium oxide equivalent and glass powder content. The low or high alkali content was not good for the strength of AASGP mortar, and the ideal sodium oxide equivalent was in the range of 7% and 9%. For comparison, the strength of AAS and OPC mortar also reported in table 6. AAS mortar had higher strength than OPC mortar. Drying shrinkage of OPC and AASGP optimism mixtures mortar versus time are shown in figure 4 up to 120 days. AAS mortar gave the highest drying shrinkage values with 0.033% at 1 day and 0.183% at 120 days. The drying shrinkage values of OPC mortar were 0.012% at 1 day and 0.07% at 120 days. AAS mortar has significantly higher drying shrinkage than OPC mortar, which is consistent with previous research results. Some conclusions are: the statistical analysis indicated in AASGP mortar the sodium oxide equivalent affected 3, 7, and 28 days flexure and compressive strength more significantly than the glass powder content, and the interaction between sodium oxide and glass powder content had no significant effect. When 3, 7, and 28-day flexure and compressive strength were concerned, the optimal value design parameters obtaining were as follows: a sodium oxide of 8.31% and a glass powder content of 14.57%. The experiment indicated that AAS mortar had higher strength than OPC mortar. The AAS mortar mixed with 14.57% glass powder exhibited the highest strength. The verification experiments indicated the experimental values matches with the predicted values from the strength models, since the percentage of error were negligible. Thank you.